No, Jesus, please. Good morning, friends. Now I am going to discuss about applied thermodynamics basics, unit 1. In the previous class, we discussed about syllabus and what are the things we are going to study, what are the topics we are going to study. In this class, we are going to study briefly about this applied thermodynamics basics. So thermodynamics is nothing but thermodynamics is a science of energy transfer and its effects on the physical properties of substance. Okay, so thermo itself it deals with work and heat. So thermodynamics is a science of energy transfer and its effects on physical properties of substance. By studying this applied thermodynamics basics, you are going to study in detail about steam turbines, how steam turbines are working, IC engines and gas turbines, power plants, what are the principles involved, what are the basic steps and how we are getting thermal power. These things we are going to study in your higher classes by using this basic applied thermodynamics. So it has a wide area. I told you in the previous class. So mainly thermodynamics is science of energy transfer and its effects on physical properties of substance. So there are two approaches to study the thermodynamics. First one is microscopic approach or classical microscopic approach. Second one is macroscopic approach. So microscopic approach, here the attention is concentrated on a single molecule, changes that occur at molecular level, whereas macroscopic is not like that. Molecule in the specific volume considered and assumed to be same throughout, same in the behavior and the analysis is carried out throughout the volume. Here comes the concept of continuum. Continuum means it must have the same phase, and not only that one, it must be a continuous without any pause. So on average, so it should be throughout the macroscopic approach should be same throughout in the analysis of your experiment or in the analysis throughout your in the study, that should be same. So most of the thermodynamic applications are macroscopic approach. Here thermodynamics mainly deals about thermodynamic approach means macroscopic approach. Why? Because here we can easily perceive with human sense. By using in microscopic approach, you can't perceive with your human sense. So only in the macroscopic approach only you can be perceived through the human sense. These things can be perceived by the macroscopic approach. Here the concept of continuum, the phase must be homogeneous throughout the structure, throughout your experiment, throughout your the case. Okay. So here interesting topics: thermal equilibrium and thermodynamic equilibrium, zeroth law of thermodynamics. These topics you are going, I think you already studied in your lower class, but regarding our subject I'm explaining. So thermal equilibrium is nothing but when two bodies are in contact with each other, so heat will be transferred from one body to another body till the two bodies attain the same temperature and the heat will be stopped. Then the two bodies A and B are said to be in thermal equilibrium. So thermal equilibrium, I think you hope you understood. When two bodies A and B, body A and body B are in contact with each other, two bodies attain the same temperature and heat will be stopped. Then the two bodies will be said to be in thermal equilibrium. Zeroth law of thermodynamics. Zeroth law of thermodynamics means it will be taken from the thermal equilibrium. Zeroth law of thermodynamics, when body A is in thermal contact with body B, and the body B is separately in thermal contact with body C. That the two bodies are said to be in thermal equilibrium. So here the body A and C, if you brought contact, there won't be any physical changes. So I hope you understand. When a body A is in contact with body B and the body B will be separately in contact with body C, then the two bodies A and C are said to be in zeroth law. The bodies A and C are said to be in thermal equilibrium. Then body A and C, if you brought together, there won't be any physical changes. Then such law is said to be zeroth law of thermodynamics. And coming to thermodynamic equilibrium, so thermodynamic equilibrium is nothing but it must be satisfied. First, it must be satisfied thermal equilibrium. Apart from thermal equilibrium, it must satisfy mechanical equilibrium and chemical equilibrium. You already know about thermal equilibrium. When two bodies or A and B are in contact with each other, heat will be transferred from one body to another body and the heat will be stopped. Then the two bodies were said to be in thermal equilibrium. Mechanical equilibrium means there is no unbalanced force on the system. Then that system is said to be in thermal equilibrium. And coming to chemical equilibrium, there won't be any chemical changes in the system. Then if it is satisfies the thermal equilibrium, mechanical equilibrium and chemical equilibrium, then that equilibrium is said to be thermodynamic equilibrium. So next, coming to the important topic, mechanical system are classified mainly into three systems: closed system, open system and isolated system. So system, everything external. So in thermodynamics we are going to study different systems. Okay, so all these things we are going to study. See, let us see, I am taking this as a system. So for a system, energy transactions takes place, energy into the system and energy out of the system. So system is surrounded by boundary. Every system is surrounded by some boundary. So that is called boundary. System system is surrounded by boundary. System apart from this outer area is called surroundings. So system plus surroundings together comprise universe. So universe is nothing but, so even the NASA declared the universe is infinite. So system plus surroundings together comprise universe. So coming to our mechanical systems, closed system, open system, isolated system. Why we are studying these systems? Energy transactions, our basic study itself, it deals with heat and work transfer. So how heat will be transferred to works and work will be transferred to heat. How? These things we are going to study in detail in the coming classes. So I am going to discuss the brief about closed system. You all know well known about pressure cooker. Pressure cooker is a closed system where the quantity of rice is fixed and energy transactions takes place. And not only that, cylinder in the piston. So these things comes under closed system. Why? Because fixed mass but energy transfer takes place. Open system. Here both energy transfer takes place and mass transfer takes place. Example, boilers, air compressors. For these, open systems are best example. So coming to isolated system, it is neither energy nor mass transfer takes place. The example is thermodynamic equilibrium. In this, neither energy nor mass transfer takes place. So these are the three types of systems. So coming to the control volume, these are the basics. First unit you are going to study. See, these are the basic topics. After that, we study the little problems. First, these are the basic topics. I told you in the beginning, these are the basic concept. Applied thermodynamics is the fundamental for your part of your mechanical subject. Unless you are familiar, it will be difficult for you. Okay, so listen carefully. It's a concept oriented. So coming to control volume, let's consider this air compressor. Air compressor. Here our main attention is concentrated only the control volume, even though air enters at one part and leaves at another part. Here our main area here our main topic concentrated on the control volume. Why? Because let us take the best example, the domestic cylinder. So how the gas will be stored inside unless you just open your regulator, pressure will be coming out. How? So if it is empty cylinder, can you experience the same pressure? You won't experience the same pressure. If the gas is in full, you can experience. If your regulator is open, you can experience high pressure. But if it's if the gas cylinder is empty, you can't experience the high pressure. So here our main attention is concentrated in this part. So control volume is nothing but the area surrounded in this. Okay. So boundary. The boundary is called surrounded the boundary surface. For this air compressor is called control surface. Okay. I hope you understand about the control volume and control surface. Next, coming to state. State. The physical properties of a state have definite value. The properties of a state have definite value. Then it is said to be a state. Properties, volume, temperature, pressure. So these are the basic characteristics of properties. Change of state. If a system, if any system, if one or more properties of changes in a system, then it is called a change of state. Path of change of state. See, let us see this one. If a succession of states in the change of state, listen carefully. Succession of state passed through in a system in the change of state, then it is called path of change of state. If the path is completely specified, see, let us take the best example here, starting from A to B. It is called process. Why we are going to discuss about process? So for regarding some systems, you have to work under some constant pressure. Let's take in the best example, domestic in summer. So as per the Indian government is designed, the air condition should be 24 degrees only. Why? Because entire India should be maintained at 24 degrees. Okay, such that you can feel some coolness inside your room. Then outside very hot and sweat in your summer. Coming to that, in winter. Air conditioning in winter, heaters are room warmers and heaters are there. You can experience a little bit warm if you maintain the temperature, if you increase your room temperature. So these things you are going to study when these things are work under certain process only. You have to use certain constant pressure or constant volume. So in previous class, regarding coming classes, we have to do some systems. That system should work under certain process only. Asentropic process, constant entropy process, isenthalpy process, constant enthalpy process, isothermal process, constant temperature process. If the path is completely specified, it is a process. So I hope you understood this small graph. So it is a process from A to B. If the path is completely specified, then it is called as process. And if this one, cycle 1, 2 and 1, so Here the path it comes 1 to 2 here, and again it goes back and reaches 1 here. A to B is a process and 1 to 1 is a cycle. So thermodynamic cycle. If a system, if it is if it thermodynamic cycle is nothing but if the final state is identical with the initial state, then it is called as thermodynamic cycle. Why? Because most of the thermodynamic process are reversible process and some are irreversible process. Irreversible process means, suppose if the process it can have only single path 1 to 2. So reversible process it can reach 1 to 2 and 2 to 1. So this one is reversible, whereas irreversible only one way. Okay. So thermodynamic cycle, if the final state is identical with the initial state, then that cycle is said to be a thermodynamic cycle. We already discussed about properties or the characteristics of the system, volume, temperature, pressure. So again, in detail, we are going to study what are different processes: isoporic process, isobaric process, asymptotic process, constant temperature process. These processes we are going to discuss. So coming to properties, properties are mainly two types. Asymptotic intensive property means independent of mass. Example, pressure and temperature means it doesn't depend on mass, whereas extensive properties depend on mass. Example, volume and energy. We already discussed the basic concept of continuum. Continuum means, so phase. What is meant by phase? If it's having phase, we already discussed. We already well known about water. Water, water. If it is in solid phase, it will be ice, and it will be in liquid state. It will be water, and it will be vapor in gaseous state. So the water, if anywhere, so single water, the component is same, but it exists in three phases. So how? So concept of continuum mainly deals about, I already told you, it consists of same phase and continuous without any homes. So why we are next we are discussing about phase. Phase means having same physical and having physical and chemical structure same. Okay. Next one, homogeneous and heterogeneous. Homogeneous means single phase and heterogeneous means more than one phase. So in this class we are going discussed about thermodynamics and what is the importance of thermodynamics, what is the definition of thermodynamics, and with these applications what we are going to study. We discussed about macroscopic and microscopic, thermal equilibrium, thermodynamic equilibrium, zeroth law of thermodynamics, system, what is meant by system, and boundary, surrounding. System plus surroundings together comprise universe. Very, very important bit. System plus surroundings together comprise universe. And these system, closed system, open system, isolated system, okay, control volume, control surface, state, properties, change of state. These are very, very important topics for your definition, not only for your B.Tech exams, for your competitive exams also very, very important. Intensive properties, independent of mass. Example, pressure and temperature. Extensive properties depend on mass. So thermodynamic cycle, the final cycle should be identical with the initial cycle. So these things are very, very important, very, very important, not only for your B.Tech, for your job purpose also. Okay. So in the coming class, we are going to discuss in detail our next topics. Okay. What is meant by irreversibility, reversibility, quasi-static process. These topics we are going to discuss in the next class. Thank you.